Hello everyone and welcome back. So today we will continue on what we did earlier today. So we had already done this just need to make sure that everything is working. Yes, we are live and everything. It's just because there's a latency that I need to make sure it's all good. But it is. Seems good. Yes, very good. Okay, so hello and welcome back. So let's finish what we were doing earlier. Yeah. Let's start by looking at again what happened, what we're doing. So now we can again create houses by clicking like this, okay? And we can now effectively we can create everything. And then in the end, I would like to clean up as much as possible. But let's see here. So as we can see here, in here we have the draw event for making the house, and right now it's red because the last criteria was that we needed to be close enough to a road. Okay, and I don't want that to be a hard criterion, but I want it to be so that, and perhaps later on, we will need to connect the house to the road in some way. Okay. And we already did a beginning. We already started implementing that aspect a little bit. But we will just make some simple criteria now. That is, we are not allowed to collide with a road or a house before. You see here, it's actually very similar to this, right? But instead of having it like this, I want there to be a criterion in a calculated at every step event. So let's just start by getting rid of all this. We can draw this circle. I mean, actually, it does not make sense. We'll just make it really simple again. Yeah. And then we'll redraw the conditions or remake the conditions. Okay, so let's go back here. So now we can see. Alright, and this where I click. Right, so that will probably be the first step. So it's where I click that it will end up. Okay, that's pretty important. So instead of having this draw I'm just thinking about this for a moment. Because we could also just say that it's the clicking itself, not the release, that would make the house. And it would effectively be the same, right? But that would kind of suggest that we don't even need the action, the house builder action. And perhaps it is true that we don't need the house builder action object in itself. And that we only need just a simple click here, right? And because we want to make it as simple as possible, I think actually that is the correct approach in this case. And I know that I'm going back and forward a lot here, but it's because there are so many things to consider. But what we will do is copy these things from here. Yeah. And now that I'm thinking about it. I would like for this, because we see we actually relatively often refer to mouse X and mouse Y, and so I would like to have that integer, like the rounded up mouse X and mouse Y, calculated at all times. And see, so actually, I think we should do that in here. So, and the question is then, how should we do that? What should we call it? Actually, that's just what the question is. What should we call that? We could call it a couple of things. Mouse X. So we have the mouse X start, mouse X, mouse Y start. That's not. And see, the thing is that the mouse X is predefined, right? It's a pretty. It's right there. So I would say. I would perhaps call it pointer, but it should not be called pointer either, because that's like a computer science term or a data term. Yeah. And so what should we do instead? And we could effectively, you know what I will call it? I will call it action X and Y, of course. And perhaps that's not the best naming convention for this, but I think that's good enough for now. And yeah, because I think I would like to replace all the mouse X and this with this exact function. So my writing skills today are not the smoothest. Okay, cool. Yeah. So okay, cool. Let me see here. Whatever. Okay. So this is, and then this should be replacing all of these. Okay. I think that's actually how to go about this properly. So I'll actually just do, no, I will not. Or will I? I think actually we will replace all mouse with action, except that one right there. Closest node to mouse kind of gets a new meaning now, but I think that's okay. But we will also replace those exactly. So instead of mouse X start, it should be action X start. Okay. And that will be put down here along with these. Okay. And then I assume that we would have to, yeah, here. So replace all of this stuff. And we could actually also replace the house angle with the action angle, but maybe that's maybe that's putting it too far. Let's just see. Okay, and for example here as well, all of this stuff. Very cool. Very good. So that's pretty much it. We can actually just delete this for now. So we take a step back. We might, yeah. Actually, let's just completely delete this. It's not that big of a deal in terms of functionality or like having to redo this. It's completely fine. So here, we can create the layer. So we can say action X, action Y, and houses, and house, and house angle. Or my bad, image angle, because that refers directly to the sprite, the mask. And there we go. So it works. I forgot that we also have to scale it up a second here. So that's also completely fine. There we go. And that should be pretty much it for now. Yeah. So we can click. Okay, so there's oh, it's drawing up there now. Haha. That's fine. Okay. All right. Yes. Seems good, everything. So now we just now we can go back and now redo the conditioning for if is this legal, right? And this is pretty simple. We can say So the thing is that we actually do want precise collisions here because we want to be able to place them effectively right next to each other if that's what we want as a city builder. So that means that we have to Let's try and see here. Collision. Sprite collision mask. Okay. Very interesting. So we could effectively. There's a couple of things here that I'm thinking about. So actually, this is ugly. I don't know if this is particularly pretty, but yeah. So now we can actually start utilizing this place here. And so we can say legal house building here, right? Or something. So we just call it, I think we'll just go back in here. We say action. Should we call it valid? Legal? Allowed. I will set as to default false. Okay. Then we can go back in here. We can say let's just keep it in here for now. Then we can draw it out later. Action allowed. Or say if action allowed, of course. If action allowed, then we do this. Okay. And I like to just have parentheses around my Boolean conditions. And now the question then becomes, because we wanted to make it easier for ourselves earlier, that's why, right? But I'm thinking if we can have, we have tried multiple different aspects here. I would have loved if we could have had, a rectangle that can rotate. But I think we have to. Action allowed. That should correspond to something very specific, right? So it should be, is this house going to connect or collide with anything? That's the simplest condition that we can probably set up, right? And that is, that's again, let's try and just have a look here again, right? So, or like, collision polygon, or, something like that. But I think what we have to do instead is, so when we click on the build house function or the action, like when we click on the button that activates our action of building a house, then we have to create an object to check that for us that has the same coordinates, same geometry as the actual house that we want to build. Okay. And we can try and see here. Okay, so action house, not house builder, but then instead it will be instead it would be house check, house check. No, but it's like check allowed, or house allower. You know what? That's what we're gonna call it for now. All right, so we can set it to the same mask as the house's mask. We can go in here, image scale, set it to global dot house scale. Image scale is the same. And action handler dot house angle. Yes. Okay. And then we should define allowed is equal to false. Okay. Okay, so now in here we can go back to the action handler. We can click on this button here. Then we can and I don't think this matters that much right now, but I'll just put it in the same house layer. Okay, so action X, action Y, houses, your action, the house allower. Okay, and that's enough for now. And so what we will then do is we will also we make a step event here. And so we have to do precise collisions. But first of all, we will set the X to yes, so that we get the exact ones. And then we can start by just looking here if this is actually okay. Yeah, that's right. I forgot to action allowed is equal to, this is actually very important. So we actually say house allower is equal to this one. Okay. This is fine for now. We will change the functionality later on if needed. Yeah, because we can generalize this later to like action allower, something like that, right? -1. Okay. Then we can set it like that. Okay, then we set action house allower dot allow. I think or not. Okay. Allowed. If that's the function, right? Yeah. Very good. Let's just try doing this one more time. Okay, so we forgot to exactly. I recognize that error by now. Thank God. All right, so we can see that we have the thing that is actually following us around. It's all good. We also need to set the this is actually to be there. Okay, so it all works. See, there we go. So it's just because it's not snapping right now to the point that it's supposed to. And that's okay. See, and now we try to click, nothing happens. Let's try and see again here what happens here. Okay. So let's go a step back, go back into the action handler. Do one step at a time. So we click here. Okay, so here it's actually strictly about the house allow. That's what we came to this conclusion, right? Now we can, I think, I'm pretty sure that we should be able to just use their own specific collision points. And the question is whether or not we should use the world solid or the road segment. But we have to, I think we have to use the world solid. Yes. And these two has to have the world solid as their parent. Yes. Good. And then we can go back up here. Okay. But I'm pretty sure that we should be able to like to do something better. To like to instead of using it like that, we should be able to. I'm just reading on this. I'll share it with you real quick. So this actually might. Okay, now I actually understand it. But that's actually what we want. As if, like as if the calling instance were to be placed in the same position. So that's, well, yes, that is effectively what it is that we want. So that's fine. So we can remove this again. Then we can say if place empty. Well, solid. Or actually, we don't even need to set if. We can just say allowed is equal to this. Yeah. And then we can, just before we finish that up, we can indicate it with a red box. Okay, so we can go back in here, and then we can say if if action not allowed, then we draw it as a red thing here. And then if not, then we just don't draw anything. We only draw the arrow. Okay. Exactly. It's exactly what I wanted. Okay, so let's try. And so it's just important. We need, I think perhaps we can do slightly more to make sure that this kind of collision point is super good. I want to see how close can I put these without any issue. And actually, maybe it actually is pixel perfect. That's really that's really my goal, right? To have it be pixel perfect. Okay. So that works effectively. So we can build houses now. Or we can so let me just take a step back. So in truth, we haven't really done anything to say that they're a house. We just making a square in the ground. And that's why we would need to civilians, and we would need this the house sprite and all these things later on to make it look good. But that's not the idea of today. It's not to make it look good, it's to make it work. And so that brings us to the next point. Let's go back. So the house itself, it has nothing right now. And the question is if we should, do the same as we did before, where we put in have a list of people that live in the house. And I would think that is the best solution. And instead of having anything up in the create event, I will try to keep it okay. So this is just an empty list, and I am not actually sure what kind of list this would be. If it is the DS list that we have talked to before, the value is one or more expressions from a list. Okay. Any code expression. Hmm. Let's try and keep it. Residents. Okay. That live in this house. And let's make a civilian object now again. Okay. Civilian. And yes, we have this, or it's actually citizen. What's the difference? Civilian is, yeah, that's a different kind of subjective interpretation. But citizen, I think that's pretty much a person living in a city. So that's what we want. Okay, and we can give him this sprite for now. That is all good. Then I think what I would like to do is have a place that I define a place that spawns. So we'll call this an outside connection that spawns the citizens. And before we had this demand handler that was kind of connected. They were put together and creating things, people from outside the world, their thing. But I think instead we would like to make an outside connection straight up like this. Okay. And this is not going to be that complicated. What we're going to do, I think something like, we'll start by just saying every second. So that's 60 frames. Yeah, and then we reset it. So every 60 frames, every 1 second, check, do we have an empty house? Okay. And how do we even check that? And that's the next part, right? So that's again what the responsibility was before of the demand handler. And perhaps we will redevelop that again, but we'll again keep it as super simple as possible. Outside connection, okay. And so we can do a couple of things here. We can say, we can make an object, call it empty house, and then say, we change from one object to another. We can have all kinds of different things here. But what I think that we will do, let me just look real quick here. So what I think we will actually do is in the object game, okay? So we will say, I don't know what to call this, so I will not call it anything right now. But what we will do here is city variables, okay? And that will be the thing is when you make them global, doesn't mean that you shouldn't really change them after they have been set. Or is that's static? But is that the same? Is there even a thing here? There is a static. I'll try to just say empty houses like this, okay? And so every time a house is created, now we will go in and now we will set a create event for it, because now it actually makes sense. Global dot empty houses plus equal 1, okay? And we of course we want it to be deterministic always. And deterministic means that the same thing happens every single time. So we make a house, it's empty, and then it will be filled with a family or a citizen. Okay. Again, we keep it simple. So what will happen is we set we have one citizen per house for now. We don't worry about families or anything like that. So one citizen moves into one house. Okay. And we will also create a outside connection. Okay. So in the up here, we can say create. Yeah, we can create depth again. Like it's object outside connection. Actually, we should. Yeah, but actually that's fine. So we have the outside connection be in the top left corner as a beginning. I think that's just fine. You don't need to worry too much about that. Okay. And then they will be created from that. The citizens will be created from that space once once an empty house exists. Okay. So now we have this variable empty houses. We can go into here again, into the alarm, and you say if global dot empty houses is larger than 0, then we can create a citizen. Create layer, and I do not remember if we actually made a layer for. We did not. So we will now make a layer for citizens. Okay, and we will call it citizens. Okay, great. And it will be the same place as the outside connection itself. And that's pretty much it. Okay. Of course, what we have to do is we have to find the empty house. Okay. And that's where it might later on get tricky again. But what we can do, excuse me, is have a list. We should either have a list of empty houses, or we should have, because we could in principle we could in principle have all the houses and then have like a list of empty houses or a list of yeah, I'm thinking out loud here. So empty houses. I mean, so the idea, of course, would be something like this. Right. And then, but then the thing is that we also have to connect the empty house with the citizen at the point in time that we are. So I think actually, yes, now that I am thinking about it, we will instead of this being a number, I would make this a DS list, dynamic something. A data structure list for some reason. Yes. Okay, so that's fine. So this is how we do it instead. Then we go back inside here. Okay, then we say we just replace it like that. Okay, and then we say. So what I'm hoping to happen is that the global, because I do not remember 100% why or what this is, but what I'm hoping to have happen is that we can just straight up remove it. Let's see here. Delete. No. Yes. at a specific position within the list. Okay, and that's fine. So for now, we will always just have the first one. So that means 0, okay? The ID of 0, the position 0. So the position 0 would mean that it's just the first one. So every time we make a house, it's empty, and then we add it to this list. And then every time a citizen moves in, it gets attached to the first house that we have on the list, and then the house gets removed. Okay. But it does not have that little pop. No. I'm just curious about something here. They have some kind of, sometimes they have some weird like structures and ways of doing it in Game Maker, but that's fine. Okay, so that's what we're doing. So we need a citizen. It should have a home, so a residence, right? And is this an instance? Let me see here. The value is an asset, but is that an instance then of the asset, or is it just the object ID, or is it the instance ID? You know what I mean? Yeah. Again, a little bit confusing. You know what? Now I'm thinking about it. It can really just it can be a number. It can be an integer. We set it as an integer. So residence is an integer. So that would be the object ID, right? Or the instance ID. Sorry, and that's an integer or a real number. So it doesn't really matter. But that's fine. And then the idea would be that we only citizens are only moving in when there exists something, and then they will do that. So it's the same as we have done before, effectively. But let's try and move on here. So outside connection. There we go. Oh, there we go. Okay. Then we will have to say so. Pretty sure that's how we write the syntax for this part. Yeah. Okay. And then we can say residence is, let me see if it actually is instance of. No? Okay. Let's try and see again. So we are in a little bit of a situation here. So let's see. We basically just want to check if our residence I mean, we can do that, I guess. If residence is equal to 0, then we just... So we don't allow for homeless people to exist right now, okay? That's it. And then we say exit. That should be fine. There. It should probably be, in the same. Okay, so instead, then we say... So now we should be able... Now the residence should be an ID of the instance of the house. And... Yes, so we'll just do it super simple again. X plus equal to... let me say seal residence dot... Oh. Yeah. Okay, so... Okay, so you'll have to calculate some things here. Okay, that's fine. So we'll just have a simple direction we just call dear. Okay, and that's all good. So now we have the dear direction. Yeah, they already have integrated like functions for this, but I do not think that's what we're gonna do. So length, we'll just have 2. There we go. Okay. And we can do the exact same for the y coordinate, okay? Yeah, because you see here, even when we... This is not... Sorry, but this is another thing I just want to point out. So in this function, seal, it takes a real and it outputs a real. So it doesn't output an integer. So it's not forced to be an integer. It's just still a real. So but now we are going in the direction of the house. Let's just try and run this. I don't know if everything is as it should be. Yes, so there we go. That's a good first start. Because I forgot to add this instead of so ds list add. So this would be, which would be added on at the end. Okay, so it's the... So it will be the last one to be created will also be the last one to be moved into. Okay. And then if I say self, but so the question is it the... Let me just game here go self. So I should actually use the ID keyword instead, I think. other instance keywords. Very interesting. They have, yeah, because they are also then relating to. Okay, now it's getting. But okay, so let's just see. If I just write ID here, it shows up as the same kind of thing, and perhaps it is the same thing in practice. I just really want to. I just really want to make sure that the way is correct or clean at least. Okay. Let's try and see. Okay. Cool. Mm-hmm. I'm trying to figure out if it's lagging or is it's because I think it's because of this the way it's snapping. Yeah, it is. It is. And that's okay. So what we'll do instead is like this. And we'll also set it to 1. Or will we? Because I'm afraid it's... No, we'll set it to 2. It's 2 will be, still be 2. Oh. Okay, and then of course we would have to... that's something I forgot to do. The square that you can see here is still there, which of course it should not be. But that's fine. Okay. So here we created. And if we... There are 2 cases in which we... There are 2... Yeah, sorry, now I'm thinking a little bit. Give me 1 second, please. Okay. That should be fine. Yeah, I think what I would like to do here, if action handler dot action, current action, dot build house or rotate or set the angle right. And of course we need to say if not that, these 2 together. We actually just say destroy. Yeah. And then of course another thing I just noticed now is, we have to in here, of course, we have to only if it doesn't, or if this doesn't already exist. Okay, so if, and then what am I doing? Very good. There we go. And yes, of course, it is very important that when we then destroy the house layer, that it has to be set back to -1 dot house allower. Okay, there we go. Like, I think this is the cleanest way, like safest way, you can say, that's to like do this. And then I would like to have these counters up here also represent. And then I would like to remove this road tool, because now we're starting to clean up as we were supposed to do. So now we can, without them, the road building mechanism, house building, and citizen mechanism, without them intersecting yet, we can still have them like work separately, but still work well. Okay. Good. So let's go into. So we have the dev interface, and this is the only one I want to have visible for now. So I think the user interface, this. Yes. So I think. No, we're not even drawing it in here. Okay. So then in here. Okay, I see. Okay. Yeah, there you see we're drawing these here. So while I think this is good, and this is actually still what I want, I don't want all the other stuff. And I don't want them overlapping with the dev interface either. Okay. So we will do a couple of things. We will say, actually we'll just say goodbye to all of this. Goodbye to all of you. And then we will put this in the bottom, okay? This is in the action handler itself. And we're drawing it as the graphical user interface. Then we have to access the user interface, like we know the coordinates of that. But instead of doing that, I'll just put it to like a high number. Like, I think it's just a full HD resolution right now, so I think that's fine. We can say 1000, like, what is it? 1080 minus 64. That's 1016. Or am I? No, it's 1006. Wait, what? No, it is 16. Well, what? 16 plus 64 is 80. Yeah. Okay. Let's just see. Yeah. Okay. Fine. And then. Okay. Good. Good. And that of course the same here. I think we will actually just have this be like the most basic. And I think actually it will just be the same in there. That's fine. Okay. Yeah. Okay. It looked like some of them were like changing direction midway. Is that true? Yeah. Okay. That's very interesting. Okay. Why does that happen? That's a okay. That's not something I can answer right here at the moment. I'm worried that that they change. So what we will do is something similar to last time, where we draw lines from the citizen and then to the let's draw a line. Let's just say here if let me just open all these. There we go. So this is the same. So we just say if residence is not equal to 0, yeah. So we draw a line from ourselves. All right, and that should be. I mean, that should be fine. We don't need to have them in all kinds of colors and everything. Let's just try and see here. Okay, I mean that works, right? Okay, I understand. It's because of the way it snaps that they change light direction. But as we can see, this works super nicely. Every person gets their own house. They go to the house, and then that's it, right? And so now we can actually backtrack and then start implementing the vehicle aspect. Okay, so the citizen itself should not be the vehicle, should not be the thing out here. It should just be a kind of a number or a struct in some way. And we can do that in a million different ways. And I'll think about that. I think I have to take a break now. So I will do that. I'll take a small break and then we'll be back in 5 minutes. Okay? All right, I am back. Just checking everything. Great. Okay. Cool. All right, so where did we come from? So we can have a couple of things here. We can have a list of citizens defined somewhere. And I think that's actually what we will do. And I don't know how far in the future should we think right now. And I think that's an how do you say, that is a, what's going on? Ah, okay, I see. An issue that I have in terms of developing sometimes is that I do accidentally think too far ahead, and then I end up getting nothing done. that's fair. But I would like to try to keep this super simple again, as I've said. So what we will do, we have a global list of empty houses. We will have a same. So we have a list of citizens. Okay. Because as far as I'm concerned, it actually does not really make sense to have all these objects that represent the citizens. Okay, so it has to be, so this citizen, we will change it into actually a like pedestrian. Pedestrian is the actual. So we will change it in here. Okay. And I don't know if that changes everywhere in the code. I'm actually not quite sure about that as it is right now. And where it would be in the outside connection, would it not? Sorry. Bro. It actually does change. So let's just try and see if that works. If it's the same functionality, you know. Everything looks fine. Perfect. Okay, perfect. So that's actually what we want. Very good. Okay. So with a couple of things have to happen here. And we'll just take a step back. We will see, okay, so in the object game, every time a citizen is created, we have to add that citizen to the to this list, okay? And instead of having it as an instance of an object, it has to be a struct. We'll call it a struct. But for now, we'll just have it be like I don't know, maybe a string of some kind, or maybe we'll actually say it is a struct data structure. I think that's actually fair. So okay, in the outside connection, here we create the citizen. Okay. And actually, what we should also do, instead of calling it citizens, we should call this vehicles. Okay. And that should be reflected in here. Exactly. Okay, great. So there's a lot of like considerations to do when it comes to naming conventions and all these things. Okay, that's fine. But what we'll do is we will actually make a small script later. First, I'll just expand upon this a bit. Okay. Okay, and we will just have two more here, which are houses and citizens. Okay, citizens, and this, of course, has to be and then here it would then be and what I'm already thinking here is it is checking the size of a list at every step smart? Answer is probably no. But I think we will dedicate a day for optimization. Okay. And so that's why we keep it simple again here. Let's just, yeah. And I of course forgot to add extra 16s here. So that's 96 and that should be 112. Great. There we go. And then we can see now. Okay, so let's just build a house. And it does not do anything up here because we don't add anything to the list. And I will also do something different here. I will say pedestrians, and that's 128. And then that should be the instance number of pedestrians, okay? Not pedestrians, but pedestrian. Cool. So that's what we do. Good. Okay, perfect. So the idea is that once the pedestrians go in their house, the instance will be destroyed. Okay, so there's no point in keeping them anywhere. And that is actually what we will do. So we say here, if point distance is larger than, I don't know. I mean, it doesn't even have to be a high number or anything like that. If then we do the thing as underneath, and we say else, we destroy ourselves. Okay. And that is actually kind of a small optimization step in itself. Not that that's a big issue right now, but okay. So let me just see here. Exactly. So then they are destroyed again. So now there's 0. There should still, of course, be 6 citizens, and that's the point, right? Now, I do have a name generator from one of my other such MS games, from the game actually that I made. And so I think actually what I'll do is I'll go in, because that's one of the things that will overlap throughout the game series. Okay. Think is this one champions. It's been a while since I've been in here. Okay. Script generate name. Yes. I will just copy all of this. Okay. And bring it back into the other. Okay. because that part is not made for yeah, it's not made to for me to stream that. Okay. And I think effectively it is exactly the same. Okay, it's just a little fun extra thing. Okay. And there are a couple of things, I guess. Oh, that was not on. I don't know what I clicked on something. Let me just see. Is anything else here good? It looks good to me. I mean, yeah, I've learned so many things throughout my many years of programming and studying all kinds of things, and now maybe there's some all kinds of different weird things. Okay. Oh, I thought we had already replaced this. Guess we didn't. Don't think this should make any difference. Everything is fine. Okay, so let's just move on really quick. Okay, everybody, when they are created, we'll have a couple of variables as a struct, right? Okay, so let's try and go in here. And how do we define structs in Game Maker? I just think about the programmers. Oftentimes it's about learning to Google stuff probably. My question: if when you have a struct, right? Is this like a common? Will this be a common pattern or a single instance? That's what I'm thinking right now. New. Well, that's interesting. What if our let me just write it here. Okay, so citizen, it will have a name and age. Let's just say that it has a name for now. Okay, so it will be an array. It will be a fixed array every time. Okay, and so when we create a new citizen, we have to create the citizen first before we do not want to, as perhaps it does not happen in here, thank God. But where it does happen is most likely in here. Yes, no, in here. Yes, exactly. Okay, so well, this is here where we should do it, definitely. That's fine. Okay, so I think that what we have to take a step back again here, and then we have to change this from residence to target. Okay, and I remember that we've done something similar before. Or actually, instead, we will call it destination. Yes, that's significantly better. There we go. Yeah. and it just has to update itself for a second here before we can do anything. So again, I'll change this naming convention to pedestrian. Okay, that's also very important. So we go back into the outside connection. So in here we create the citizen for which so we create a citizen that will be just an array. Okay, that should be perfectly fine. So okay. Oh. So this will be an array of one string. And then, I'll just say 30. Just want to see if does it change. Yeah, any. Okay, perfect. Okay, so let's keep it like that. So we have the 30 is the age of the person. So everybody moving in is 30 years old. Okay. And then we say and then we have to say, so we have to have two here. So one would be citizen. This is not defined. And I wonder if I can write like array any somewhere to declare that type, because I do not like the way they have type checking in. And this is gonna be any code expression. Or what is like? Yeah, I guess so. So this can be an array of any at some point, right? That's what we want it to be. So the pedestrian will be representing the citizen. Okay. And then now I can do something a little bit more fun, which is draw the name which is that, and then because you'll see my funny generate name algorithm in a moment. Let's just see. I don't know if this. I have a feeling that this is not going to work in itself. Yeah. No, I did not expect that. Not set. Okay. Step 1. Line 1 in step. Oh yes, of course. It's not residence anymore. This is destination. Destination. Because the resident variable that is going to be defined at some point, that has to be in the house of the citizen, not the pedestrian. The pedestrian is just a carrier. Again, let's see. In the draw event, okay, so it's the same. I was a bit too fast. No, sorry. We could take this even a step further, but we will not do that right now. Let's try and see now. We have Drem. We have Silum. We have Espel. Koiksan. Egte. Jean. Susan. Nixon. These are all very funny. Like they're supposed to be a little bit mystical names, that are heavily, yeah. But you can see that they. And then later on, we can make family names and all that stuff. So that's really fun. That's cool. Okay. Let me think. So what will the next step be for us now? So we have actually already done a lot today, but I want to keep going. I want to keep going. And if there's anybody out there that is following along, because I can see there's a couple of people in my stream, leave a message in the chat so I can see where if there's anybody who's here with me. And now we can say, okay, so what are we gonna do next? We can start going with the path finding, right? Yeah. And we were working with this for some time last time, or the time before, perhaps. Let's go and see here. Do we have anything regarding that here? No, we don't. And I think that's fine, okay? So, we can think about for a second, how do we want to how do we want the pathfinding to work? And we're going to follow this A star algorithm at some point, right? But we can do something significantly easier now. And so a couple of things that we should do is we should first define closest node to the house and the closest node to the citizen at creation, at point of creation. So I want this to work whether or not there are any roads as it does now, okay? At the same time, you should not be allowed to walk through another person's house to get to your own house. That's one of the things, right? But that's good. So we have the pedestrian. And the question is then, which aspects or who should be responsible for what, right? And so the house has a node, or the house could have a node. We talked about that last time as well, right? The house could definitely have a node that it would be connected to, so that they could, let's say, drive in and all that stuff. That would be more relevant once we have cars involved. It's not very relevant right now. So let me think about this for a moment. So the house the house should have a closest node, and the citizen should have a closest node. Okay, that's fine. Or the pedestrian. So let's just do that first. Here, okay. Closest node is equal. Oh, I have to probably. -1. Okay. If instance exists, if any node exists, then we can pretty much just set it nearest. And you know, I actually like that closest or nearest. That's an interesting aspect. Whether or not instance nearest, if it should be called nearest or closest. I mean, perhaps it does not matter that much. But that's pretty simple, okay? And we can copy this into the house, okay? Wait, what? Ah, yeah, of course. And this is actually just the exact same thing, right? And then the path finding should then be in between the closest node of the citizen and then the closest node of the pedestrian and the house. And then it comes another question. Should that be done, like should that be calculated all at once? Or should it be calculated every time we go to a new node, right? And that is actually a super good question. So for optimization later on, we would definitely have to do it dynamically through time, but could we effectively do it easier now or simpler now? Do it in simpler fashion now? And so it will be simple, right? So if there's a -1, then we just walk straight to the thing. Okay. We also have to think about avoiding things or following certain lines. These are all kinds of weird aspects that I want to have be a part of the game. Okay. Okay. So here, if closest node is equal to -1, actually all this here will be put in here. Okay? Else then we would have, I mean, we could effectively copy paste this entire thing and then just say that instead of replacing the destination with the closest node, okay? These would effectively be the exact same things. And so let's see here. If we now we have a node and a node here, okay? And so the fact that it exists exactly like that. Okay, great. And of course this should not happen down here. There we go. As you can see here now. Exactly. And that, of course, should also be represented here. And excuse me for a moment, I just have to really think through for a moment here. Because there's like a couple of things to consider before we go too deep in here. So, closest node. I mean, I mean, this actually, I can do whatever. It's completely fine. Let me just draw a line to the closest node. That's fine, actually. Let's just do that for now. See. Right. So we can build some nodes and we can have them go to that node first. Why would they do that? Now we need to give them some kind of incentive to do it. Right? Why? When is walking straight through grass and shit? Sorry, excuse my language. When is that better or worse? And so we have to calculate a distance, okay? And then we have to calculate a... I'll try to explain it real quick using the roads here. Okay, so now we just have a tiny network here, okay? So we know that our citizens will come from up here. And then they will go somewhere here, okay? So if the house was here, of course, this is not the way to go, okay? Of course, they should not go to their closest node first, okay? But let's say it's here. Then I want it to be worth it for them to go through here and all this. If they're just going in straight line, okay? So there should be a penalty for walking in grass, and I think I've also addressed this before, but this is the kind of thing that we are starting to do now. Okay. So the next step is then to say, okay, the node that we have, the closest node. No, sorry. We start with a distance, okay? So the pedestrian will be let me see here. Are we haha, yeah, so see here. So just say dist is equal to 0. Okay. Again, this is super important. It's so important to have like each functionality be super simple in and of itself. Okay. Oh, now I made a mistake here. Distance. This is the one I want to save. Okay. So I actually can do like this, and then we can say dist. Okay. And distance. And this will always have to be the distance to the destination, not to anywhere else. Okay. And then if we think about the A star algorithm, if I remember correctly, it is kind of an optimistic approach where you think you can go straight. You can go straight towards the house. And this would be in a maze, right, where there are walls. So there it's a grid where some of the things are connected, or some of the cells are connected, and some are not. So there are walls in between them, and in some places there are not walls in between them. And I think I'll read up on that. At another time, of course, I'm not going to waste anybody's time with that. Here. Okay. But we can do one simple thing before we move any further, okay? And that is to say, if we can copy this. Yeah, sorry, it has to be down here. Between the closest, if the distance between the closest node and the destination is smaller than our destination, then it's worth going there, right? So is smaller than the, okay. All right, and that's exactly what what kind of thing we need here. Oh. It's smaller than dist, or equal to. Let's just say that. That's fine. Then we can perform all of these actions in here. And if it's not worth it for the player, for the pedestrian, so let's try and just set a point here, okay, and then just have it there, okay. That will go here, okay. But if you make one closer here, yes, okay, I see. Then it will no longer recognize it, and then I think actually what we should do is to set the closest node back to -1. Else, closest node is equal to is equal to -1. There we go. Okay. Because then now it should be able to exactly, right? And then in this case, it would we would like for it to go down. And then until it no longer is worth it for the pedestrian itself, then it will change. Okay. And this perhaps is something we should also do like or occasionally, not every single frame step thing. Okay. Hmm. Now we can think a couple of things about, like, we can think, um, hmm, I'm rambling. Excuse me. So the next thing would be then say, okay, where's the next node, right? So we would have to, this functionality in itself is actually pretty good, but we would have to have it work not dynamically. We'd have to work dynamically. Um, and so we would do a couple of things. So a node, if it's closer to, if it's close to a, no, it's not close. If the node is connected to a road, if the node is connected to a road, then we can follow that road from the start node, or from whichever node it is that we started from, and then to the other node. Okay, doesn't matter if it's the start or end node. And so let's try and look at that part. So now we can start overlapping, integrating the the pedestrian functionality with the road network. Okay. And I remember we do have a bit of functionality regarding this in the old one, but as I said, I want to redo this because it became tedious and tangled in a bad way. I didn't like it. And so what I think would be good, right? If we have a closest node and it is like it is closer to the destination than our just walking straight through or whatever. Then we can start. So it's in this particular case here. Okay. And here we could have actually say, instead of calling this the closest node, I would like to call it next node. Okay. or sub. So we had, remember we called it sub target before, but I don't think it makes sense to call it sub target because it will always be a node to be the sub target. It has to be a node. So we will call it next node, okay? All right. And here we can effectively change all of this, and I think actually we will, to next node. Literally all of it. Yeah. And I believe that this should work just as well as before, unless I've done something wrong. No, but it looks good. Okay, perfect. And we can also ask ourselves how much of the actual like node should we use? Should we be able to, just walk off the road? It doesn't have to be like at a node. But I think to keep it simple, we can just say we only work with nodes for now, and then we can expand on the implementation later on. Perfect. And then we can do a couple of things here. So we can kind of like we can now ask the destination, the house, where is that closest node? And how do we get from where we are now to that node? Is that what we want to do? It is. Is it that? What is that? What we want to do now? And right now I'm thinking deeply about why do we want this like funky behavior for the pedestrians? But I will stick by it. I will stick by this. The idea that they should be able to move in space, like in real space. If that makes sense. And they don't have to have be connected to a lane or a road of some kind. Okay. So let me look here. So we have road segment that is a collection of lane segments. Yes. Lane segments, are they ever defined? Do we define them now as such? As far as I'm concerned, no. It's a collection of lane segments between two nodes. Yes, I agree. But I don't think that we are actually doing anything with the lane segment. I don't think they're ever in play. Unless they are in here, maybe. Okay, good. I was confusing myself here for a moment. Very good. Okay. And so what we should do is basically let the pedestrian ride on the lane as if it was like a roller coaster or a train, you know. So we define for the lane segments. Let me see here. Are they defined? Beautiful. This is perfect. And so we have actually been smart in the past, surprisingly. Okay, that's great. Let me see then. Okay, so we need to identify the lane that starts at the node that we are going to, not ends at the node, okay? So we have a directional lane. That has to be directional. And perhaps later on we can make a non-directional babadaba, but we need to have the let me see. So when we create a road segment, we add the forward lane and the backwards lane. I would prefer to call this forwards lane. Why not forwards? I think so. Yes, I would. Looks good though. Otherwise. And we can actually see here. So the way that this is implemented, we have a start node and an end node, and we have the forwards lane goes from start node to end node, and the backwards lane goes from end node to start node, right? And so we can identify the node. We can say, okay, is this node connected? And let's just go in. Let's do it in here for now. Okay. Path finding. Okay. And I will write a bunch of comments in here now. Okay, so if if it, let's say, if it makes sense to travel across lanes, roads/lanes, do so. Otherwise, walk in grass. Let's just say it like that. Okay, that's pretty simple. Then the next comment is determine closest node. Okay. Determine any nodes along the way okay for next node. Let's just say determine next node if relevant. For next node, determine which road to travel from, or to travel with, to travel on. Okay, so we look at a node, the next node, if the next node exists. Okay, so now we are in a point here. Okay, this is in here. Okay, but this is in the step event, and so we will again generalize this at some point and make it less so I just zoned out here for a second. Yeah, okay, so now let's say we are at the node. Now we have walked to the next node. That's great, right? And so here we have to update what is the next node then going to be, right? And so either we set the next node to -1 or we set it to a new node. And if you set it to -1, then it would only make sense that then we just walk in a straight line again towards the destination. And so so now we are in a place where we have moved to the node. Okay, so let's say here. So the node has a DS list of roads called roads. Okay, great. So let me just open up these. No, this is fine. If next node dot roads, okay, if DS list size, okay, var r as roads. Let's say potential roads is equal to this. Okay, number of, we'll make it really explicit now. Okay, if it's equal to 0, then next node is equal to -1. Else if is equal to 1 exactly, then next node will be equal to then we have to do a little bit of calculating. So we can say here we can just first we can just have determine next node if relevant. I mean that's yes, determine next node. And so for this, we would just have to say, okay, we have two. There's a two. There are two. There's one road, so there are two nodes in the road, and we have to choose the one that we are not already on. Alright. Okay, that should be pretty simple. So if there's exactly one road, then we just then we say var road is equal to the only road that there exists. Let's just say chosen road. Okay. Then we say, okay, so the chosen road, we know that it has a start node and an end node. And we also know that it has two lanes, right? And what I would like to do is that all vehicles, and we'll later on, implement the vehicle thing, but they should be attached to a lane, not to a road, not to anything else. It should be attached to a lane. Okay, so let's say current lane, okay, and that can also be -1. That's fine. Good. And so here we can now determine if the node that we have found is set the road start node or end node. Okay, so if chosen road dot start node is equal to next node, yes. And I think, yes, we'll do this before we actually force the lane implementation, but we'll do this first. So we just set the new node. Okay, so if chosen road is the next node, then we set the next node to chosen road dot end node. Yes. Yes. And that would be the purpose of the road segment in itself. Why? So yeah. Otherwise, why would we want to, save the values and all that stuff? And then we just say else next node is equal to chosen road dot start node. Okay. And while we're at it, let's just also implement the lane. Okay, current lane. And so if the next node that we have to go is the end node, right? That would mean that we are going from the start node to the end node of the road. This is so a tedious way of talking about this, but okay, that's fine. So chosen road dot the lanes Okay, that would be the first of those two lanes that are in the road, because that's the forward lane, right? And that would then be here. It would then be the B1. All right, all right, all right, all right. Let's see. Um, I'm not expecting too much. Uh, as I said, I'm not expecting too much, but oh, okay. Wow. I mean, let's just. I want to make sure you know that. Uh, I mean, I'm kind of excited right now. I, I'm curious about like what kind of. Okay, so we have we have managed to. I don't know. Yeah, I'm not quite sure. Okay, let me just restart the game. Um, I want to just like make like a small grid here. Uh, so. Okay, so we have. Looks good. Okay, and then we can, if let's say I put a house here. I just want to see what happens. My yeah, it could be a couple of things here. So it choose. Oh, okay. It's okay. But still, it's the same node we're choosing here, and let's just say it's going there. Okay, that's fine. Okay, but so the idea I think is I like the way that they walk, but I think hmm. My issue is that it does not update. So that's of course. Yes, of course. It's because um, this is only in the case of one road connected to it. So let's try to recreate the example, but just with one big long string of roads like this, okay? Or segments of roads. So what I'm hoping to have happen is that they will. And that is not what happened at all. Okay, so now we can say, okay, perhaps. And oh yeah, of course, this is redundant. Not redundant, but next node. Yes. I would like to just say. So for the destination, we draw a white line, and for the next node, we draw a blue line. Okay. And for the text above them, it will be black. So let's just do the same thing again here. Let's try and see here. So, I already know the issue. I just remembered because this has two. It has two, not one. So it has two. So it can choose this one, and it can probably choose the next one. Yes, but it cannot choose again after that. In this case, I don't know why it did that, but it chose effectively to do nothing, or like just to ignore it, and it's same there. It's interesting. Yeah. And sometimes we end up in this situation where it doesn't want to do. So we are definitely in a bit of we're in a place where there can be done a lot of improvements. Hmm. And you know what we'll just do for now? We'll do the same like this, right? Hmm. Yeah, so because we're not following the lanes, actually, this is why it happens like this. We're just like directly looking at the notes and everything else. But that's okay, you know. But that would probably be the next aspect, right? So for this case, specific case, this makes sense. For this case, it makes sense too, but it's because we have not yet considered the current lane. But we do set it now. We do set it down here, so that's perfect. Okay. Yes. And I guess that would be the next step, right? So here, excuse me. So here, that would be if point distance to the next node. This would be if indeed the current lane is also equal to -1. Okay, so let's just say current lane is equal to -1. And then we would have to completely change the conditions for setting this up in the first place, which is also okay. But we're just trying to put these two in themselves. So if current lane is equal to -1, that means and hmm. And then becomes like, is it? Okay, now I understand. It's because this has to be inside of this. Very good. Okay, so if the current lane is equal to -1, then this is how we do it. Yeah. Else, we would have to, hmm. So we can, you know what we can actually do? Because that would actually be a good time to have an exception for this rounding up that I would like to have. So that would be when they're directly connected to the lane. And so there's a few things here. So we have to, the lane has to have Well, it has a length in theory, right? It's not explicitly calculated, but we can calculate it now. Var length, lane length. Okay, and that would then be a point distance from start x1 or start x. I don't remember exactly. Start x and into, okay, perfect. That's fine. Okay. So now we calculate this explicitly here, and then yes, and it always has to be the like we always have to follow the direction of the lane. Yes, very good. Okay. Now I don't like defining these variables over and over again, these temporary variables. This is what we will do though for now. And we will optimize it. I just have to remember to remind myself of that too. Very good. Um, then we can fix our x and y coordinates on the lane and in between those 2 points. And I'm just thinking exactly how we should do that. And it will be something similar to this up here. Okay, so I'll just copy it for now, but it will not be exactly the same. So, you know what? I'll just keep it like this. Okay, so is equal to yeah, I'll just do it completely explicitly instead of being smart about it. Because it often ends up. So the x and y will then be the thing, the this, okay, and then we need to have another value. Say lane current lane traveled, okay, is equal to 0, and that would then be I would like for this to also return an integer, and so we will just round this one up. Yeah, just because I want to. Okay, so here we can now say, okay, plus length. I mean, yes, we could do this, and that's, you know what, let's just do it. And then we can say lane length and lane direction is equal to, and here we need to, it needs to be, it needs to be specific. Or it can be a float. That's okay this time. And perhaps we will change it again later. Point direction from these places, yes. And so it will be is equal to this, and The first is the length, and so that would be lane traveled, current lane traveled, and the lane direction. Okay, so now we are fixing our coordinates to the lane, and that would be the same there. Yes. And then of course, the current lane traveled would have to be, so that's what we're going to do up here. Current lane traveled plus equal to 1, 2. And I'm not sure where we are right now. Oh, well, I mean, it would be great if I actually built some roads for them to travel on. And I'm being quite silly right now. Okay, there we go. See, yep, snapped completely to it. Yes, perfect. So see, it goes to the node. Yeah, that's exactly what I wanted. It goes to the node, it snaps to the lane, and then it stops right there. Perfect. It stops when the distance is no longer worth it. Like the disc going finishing on the node is no longer worth. Beautiful. And that's exactly where I want to end today. And that's super nice. So in general, unless it makes sense for them, they will snap directly to the lane and use that directly. That's perfect. That's exactly the kind of thing I wanted to have happen. Now, of course, there's a couple of things like we have to walk into the house through the door. That's a couple of things. That's a thing in itself. And these smaller behavioral changes. But this was really the aspects that I wanted to discuss and address for now. And I'm very happy with where we got today. So thank you for participating. This has been great. And I will see you guys next time.